Welcome to the GH Addition Math and Science Clinic for BC candidates. We are available on Sundays from 3 to 6 p.m. using our various handles on GH Addition TV. Now, this lesson is Science Lesson 3, and the topic for discussion is matter. We began matter in the previous lesson. We spoke about the states of matter, how one state can be converted to the other. In this lesson, we'll be looking at chemical compounds and simple chemical reactions. So in the previous lesson, we studied matter. We looked at the states of matter. In number 8, So our lesson objectives would look at what a chemical compound is, how they are formed. Then we'll talk about binary compounds, compounds made of two elements or atoms, and then how their equations are formed or symbols are derived. Then we'll look at chemical equations. So what is a chemical compound? By definition, it's a substance formed from the chemical combination of two or more elements. So a compound is formed from the chemical combination of two or more elements. So the basic thing is two or more. Now examples include water. Water, you know, is H2O. And then common salt, that is NaCl. So water as it is, it's made of hydrogen, two hydrogens, and an oxygen. And common salt is made up of sodium and chlorine in a 1:1 ratio. Now compounds have different characteristics from the elements that form them. So for example, if we take sodium chloride, common salt, we eat it every day. If you want to single out the components, if you take sodium reacts with water very rapidly. If you take chlorine gas is also poisonous. So if it were to be a mixture, then there will be some poisonous nature and then some reactive nature with water. But because it is a compound, different from a mixture, it has been chemically combined. Sodium chloride is safe to eat, but then sodium as an individual and chlorine as an individual, with respect to their properties, is very harmful. So that's a chemical compound. Now compounds can be used in various ways. It's used in medicine. The chloroquine you take, aluminium trisilicate, or what you call gin, all these are medicines that are chemical compounds. If you come to agriculture, we have fertilizers, NPK, we have pesticides, we have weedicides, etc., etc. Now all these are chemical compounds. Then when you go to industry, you can talk about soda, you can talk about paint, you can talk about turpentine, you can talk about grease, etc. All these are compounds produced in industry for use. Then when I talk about energy, in energy you will need gas, and gas is a compound. You have methane gas, ethane gas. Your liquefied petroleum gas is a form of a compound. The LPG gas, liquefied petroleum gas. Petrol used in the cars daily, diesel used in cars daily, kerosene. All these are compounds that are useful in producing energy. Now we move on to binary compounds and their formulas. Now compounds can be made up of two or more elements. Binary compounds specifically are made up of two elements, but compounds in general can be made up of two or more elements. This was stated earlier above. Now the chemical formula of a compound shows the type of atoms and their respective numbers it is made up of. So if you see a chemical compound, the formula will tell you what the atoms are, which kinds of atoms are included in there or mix it up, and then their respective numbers. So for example, if you take H2O, H2O is for water. Now it is made up of hydrogen and oxygen. So the kinds of atoms are hydrogen and oxygen. Then their respective numbers, there are two hydrogens and one oxygen. Two hydrogens and one oxygen.
So now let me deal with the subject of valencies. So valencies, what are valencies? The available vacancy or slots in a shell that can be filled or lost. Now, if you are writing the electronic configuration of, say, carbon has 6 electrons. If I write in the configuration, you write 2, 6. Now the 6 at the end is on the outermost shell. Now for a shell to be stable, it needs to be filled to 8. That is what we call the octet rule. So for you to determine the valency, from 1 to 3, you lose those electrons. So if you have the outermost shell having 1 to 3 electrons, you lose that electron. So if a substance or an atom has the outermost electron as 1, the valency is 1. Outermost electron as 2, valency is 2. Outermost electron as 3, valency is 3. But in that case, they would always lose that electron to become stable because it is smaller than 4. Now, when your outermost shell, after writing the electronic configuration, the number outside is the outermost shell's number of electrons. When the outermost shell has 4 electrons, then it can either choose to lose or gain. So like I said, carbon has 6, 2, 4. Carbon can choose to gain 4 or lose the 4. But most often it will go into a partnership and share the 4 with another compound. Then we go to atoms with 5 to 7 electrons. When they have 5 to 7 electrons, they would gain 5 to 7 electrons, they would gain electrons in addition. Meaning that if an atom or an element has 5 electrons on its outermost shell, then the valency is 3. The valency is 3. If it has 6, the valency is 2. If it has 7, the valency is 1. So the example I've given, oxygen has 8 electrons, and the electronic configuration is 2, 6. Oxygen has 8, so 2, the last one will be 6. Now, each outermost shell or each shell can be filled to 8 to be stable. That's the octet rule. So when you are filling, you fill 2, 8, you don't continue, go to the next shell, 8. Now, for the shell to be stable, it has to obey what we call the octet rule, or having 8 electrons on the outermost shell. So oxygen having 2 and then 6, the outermost shell is 6. So oxygen needs 2 more to become 8 on the outermost shell. So the valency of oxygen is therefore 2. Now the second example, carbon has 6 electrons. Carbon has 6 electrons. And having 6 electrons, like I explained, is 2, 4. So it will need 4 more to obey the octet rule, making it 8 on the outermost shell. Now, once it wants to obey the octet rule, the number of electrons that will be taking place there is what will give you your valency. So that's how valency is determined. Now, naming of binary compounds or naming binary compounds. Naming binary compounds. Now, to name binary compounds, the valency is very, very important for you to achieve that. So, for example, if I tell you carbon dioxide, it is carbon C, oxide for oxygen O. Then I will look at their individual valencies. So, carbon has a valency of 4. And I expect that by now you know why, because the outermost shell of carbon is 4. And you need 4 more or lose 4. So the valency is 4. And oxygen has a valency of 2. The valency of oxygen is 2 because oxygen has 8 electrons. If you write the electronic configuration of oxygen, it is what? 2, 6. Now the outermost shell being 6 will need 2 more electrons to become octet or to become 8 or to obey the octet rule. That is why oxygen has a valency of 2. Then our next step, In our next step, we would have to interchange the valency. So although carbon has a valency of 4, we write 2 as a subscript. And although oxygen has a valency of 2, we write 4 as a subscript. So C2O4. Now earlier I mentioned that when you have the values as something you can reduce to lowest term, you do so. So carbon has 2, oxygen has 4. This can be reduced by a factor of 2 to become 1 and 2. So reduce to lowest ratio to become C1O2. But whenever there is 1 as a subscript, we do not write it. That is why carbon has CO2 as its binary compound form, CO2. Now let's look at our almighty sodium chloride. Sodium chloride, as we know, is common salt, the salt you take in every day. Some of you abuse it and it has a later impact. So please don't overtake common salt. Just mild to make your food taste good. All right. So sodium chloride is made up of sodium and chlorine. Sodium and chlorine. Now before we can write the binary compound of sodium chloride, we would need to know the valency. But before you can even find this valency, you need to know the number of electrons. So sodium has 11 electrons. Sodium has 11 electrons. And this is written in the form 2, 8, 1. 2 first, 8, making 10. You don't put 9 there, you leave the remaining for the next shell, 1. So the outermost shell of sodium has 1 electron. Earlier, I told you that when it has 1 electron, 2 electrons, or 3 electrons, it will prefer losing it to become stable and to obey the octet rule. Because according to octet, for stability, the outermost shell needs 8 electrons. So 2, 8, 1. So the valency of sodium is 1. Now let's take chlorine. Chlorine has a symbol Cl, has 17 electrons, and I expect that by now you'll have memorized all that. 17 electrons, and in arranging it is 2, 8, 7, making the valency 1. Why is the valency 1? Because the outermost electrons are 7. And when it has 7, it will prefer taking on 1. That 1 it takes on gives it a valency of 1. So to write your binary compound of sodium chloride, you write Na and Cl. Now, like you know, they would interchange their valencies. So the Na1, the one down there is the valency of the chlorine. And then the Cl1, the one there is the valency of sodium. So it has been interchanged. You are seeing it so because it's 1, 1, but then it has been interchanged. But finally, because we don't write 1, we will leave it as NaCl, as the binary compound of sodium chloride. So sodium chloride is not just NaCl because it's made up of sodium and chlorine, but because of the issues of valency and then how binary compounds are derived. So we take calcium chloride. Calcium Ca has 20 electrons, 2882 when we put it in the configuration. Now, once it has the outermost electron of 2, the valency is 2 because it can lose those 2 electrons to assume an octet state. And chlorine has 17 electrons. Like we did earlier, it has 2, 8, 7. The 7 would rather prefer taking on an electron, and that means the valency becomes 1. So calcium and chlorine forming a binary compound becomes CaCl2. Why? Ca has a valency of 2 and chlorine has a valency of 1. So we interchange these two numbers so that Ca's valency of 2 will become chlorine's subscript, and then the Cl's valency of 1 will become calcium subscript. So calcium subscript will come down below calcium, and then chlorine's subscript there. Now the subscript of 2 or the valency of 2 for calcium is now at the chlorine, and the valency of 1 of chlorine would have been placed here, but like I told you earlier, we did not put any value there.
So we look at chemical equations. Now we say that a chemical equation shows the formulae of the substances that are involved in the chemical reaction, and this leads to the formation of a chemical bond. So in a chemical equation, we have the mathematical representation of the various reactants, that the substance that combined, and the products, that the substance that were formed after the reaction. And once this reaction takes place, there is a formation of a chemical bond between the new substance that is formed. That is why you can't easily separate a chemical reaction than you can do for a mixture or a compound as against a mixture. Now let's look at how to balance simple chemical equations. So first step is to write down the word equation. Say carbon plus oxygen, and it will form carbon dioxide. Then your next thing is to write the symbols for the reactants and products. So for example, carbon is C plus oxygen is O, but to write O2 and I'll explain to you why. And then it will form carbon dioxide. Dioxide means two oxides. Now this outcome you can do by looking at the binary compounds we did earlier, looking at the valency and all that. It will help you find this one. So even if you don't know, you can determine that. Now in writing these reactants, whether it's supposed to be C2 or C or O2 or O, note these. Oxygen is written as O2, nitrogen is written as N2, hydrogen is written as H2, chlorine is written as Cl2. So bear these in mind. At least for a level, you need to know this. Then all others such as zinc, sulfur, calcium, potassium, etc., etc., sodium, they are all written without a subscript. So they are single atoms. So please bear that in mind. Bear that in mind. Then the third point is to balance the number of atoms on both sides of the equation. So on the left hand side, if you have 4 carbons, on the right hand side you are supposed to have 4 carbons, just like you do for a regular equation, that is in mathematics. Now in doing this can be done by changing the coefficients of the compounds but not the subscripts. So you can change the coefficients but not the subscripts. And by coefficient you mean this: 2C, the 2 is a coefficient. C2, the 2 is a subscript. So you can never touch this 2 here, but you can always manipulate this one to balance your chemical reaction. So in balancing your chemical reaction or equation, you can, after writing it out, you have to balance the number of atoms on both sides of the equation. But this can be done only by changing the coefficients. You can't touch the subscript. And please bear this in mind. Forever it remains so even in secondary school. So bear that in mind. Now let's look at this. So we want to form water, and we are combining hydrogen and oxygen to form water. Now in the earlier slide we told you that hydrogen goes as H2, oxygen goes as O2. Both are gases. Now if these are binding to form H2O, it means that we need to balance the number of hydrogens on one side, number of hydrogens on the other side, and same for oxygen. So now let's look at the left one. How many hydrogens do we have? We have 2. How many oxygens do we have? We have 2. Right hand side, how many hydrogens do we have? We have 2. How many oxygens do we have? We have 1. So you realize that on the right hand side there's a shortage of 1 oxygen. shortage of one oxygen. So how do you go about this? Now, to get 2 oxygens on the left hand side, if we bring 2 in front of this, it will increase our number of oxygens here to 2 for the right hand side. Why? Because the 2 in front is affecting the whole atoms there. So the 2 here affects the oxygen to make it 2. Now the 2 here affects the hydrogen, but the hydrogen also has its own subscript of 2. So in effect, hydrogen now would have 4. That's 2 times 2, 4. So on the right hand side, after bringing 2 in front of water, or H2O, oxygen has successfully become 2, like it is 2 on the left hand side. However, hydrogen has increased to 4. So there's still a problem. Now if the hydrogen on the right hand side is 4, and the hydrogen on the left hand side is 2, what can we do to the left hand side to make it have 4 hydrogens too? Now remember I told you that you can only write a coefficient, but you can't change the subscript, the numbers down. Now you realize that when you put 2 in front of this, 2 times 2 will make 4. That will make the number of hydrogens on the left hand side 4. Now that 2 here doesn't affect the oxygen because it is not the same compound or element. There's a plus, meaning there are 2 different elements coming together. Now if it is so, then the 2 in front here makes the hydrogen here 4, the hydrogen on the right hand side is 4, oxygen on the left is 4, oxygen on the right hand side is 4. So in effect, our final chemical equation balance is this: 2H2 plus O2 forms 2H2O. And that is our balanced chemical equation. We call the equation balanced because the number of atoms on the left hand side is the same as the number of atoms on the right hand side. So we go on to the next one. So in this one we have potassium and chlorine. Potassium and chlorine. Now like we said, chlorine would always have a subscript of 2, but then potassium is 1. Okay. Now let's look at the number of atoms on both sides. So potassium K is 1, chlorine Cl is 2. Right hand side, potassium is 1, chlorine is also 1. So you realize that on the left hand side there is 1 potassium, right hand side 1 potassium, but on the left hand side chlorine is 2, on the right hand side it is 1. Meaning we need to increase the one on the right hand side to become 2 like the one on the left hand side. Now the KCl here is 1 compound, and to make the chlorine 2 on the right hand side, we can only bring a coefficient, a number in front of the KCl. That is 2 in this case. Now when we bring 2 to the right hand side, potassium now has become 2. Chlorine 2 has now successfully become our 2 of interest. So in effect, this chlorine and that chlorine have 2 each. Perfect. However, potassium on the left hand side is 1, potassium on the right hand side is 2. Meaning that we have to find a way of increasing the potassium on the left hand side to 2. Now there is the potassium, it is only 1. And how can we make it 2? I've told you that you can't write subscripts here like this. No, never do that. It is not right. So the only thing will be to put a 2 in front, a coefficient. Once you put that 2 in front, that 2 affects the potassium. It will let us have 2 potassiums. And then throughout you have potassium 2 on the left hand side, on the right hand side, chlorine 2 on the left hand side and on the right hand side. Now let's look at magnesium plus oxygen. Magnesium plus oxygen forming magnesium oxide. Now the MgO has been formed because valency of magnesium is 2, valency of oxygen is 2. So when they come together, there will be Mg2O2. Mg2O2. But I told you this can cancel out. Become MgO2. That's why I have MgO over there. So don't be surprised we finalize that. So now let's solve our balancing of simple equations. Left hand side, magnesium 1, oxygen 2. Right hand side, magnesium 1, oxygen 1. Where is the problem? The problem is that there are 2 oxygens on the left and there is 1 oxygen on the right. Now once there are 2 oxygens on the left and there's 1 oxygen on the right, you would need to find a way of increasing the oxygen on the right. So it has to become 2. So what do? You put 2 here in front of the MgO. Now when you put a 2 there, that 2 affects everything. So Mg, which was originally 1, now becomes 2. And then oxygen, which is originally 1, also becomes 2. Now once oxygen becomes 2, and on the right hand side and on the left hand side, oxygen is sorted out. However, you realize that magnesium is 1 on the left and magnesium is 2 on the right. If this is the situation, then we will need to increase the magnesium on the left to 2. Now, you can't write a subscript 2 here, it is not allowed. So you put 2 in front of the Mg. Once you put a 2 in front of the Mg, it affects the Mg only and then it makes 2 here. So Mg2 on the left, Mg2 on the right, oxygen 2 on the left, oxygen 2 on the right. And that gives you a new balanced equation as 2Mg plus O2 becomes 2MgO. And this is our balanced equation. Then our final one. We have calcium plus oxygen forming calcium oxide. And like I explained in the previous question, calcium has a valency of 2, oxygen has a valency of 2. So even when they interchange, it becomes Ca2O2. And then you reduce it, it becomes Ca1O1. But we don't write that. So it's CaO. That's how come this is what it is. Okay. Now let's balance our equation. Calcium on the left is 1. Oxygen on the left is 2. Right hand side. Calcium on the right is 1. Oxygen on the right is also 1. So you realize that calcium on the left is 1. Calcium on the right is 1. Oxygen on the left is 2. Oxygen on the right is 2. There's a problem. Wahala don't come. So if this is the challenge, what do? You have 2 oxygens on the left, 1 on the right. So you have to increase the 1 on the right to become 2. So what do? You bring 2 here. Once you bring that 2 there, it affects the calcium, making calcium 2. It affects the oxygen, making oxygen 2. So you have 2CaO. Now on the left hand side, you realize that the calcium on the right hand side is 2, but the calcium on the left hand side is 1. Meaning that we need to increase the calcium on the left hand side to become 2. Because this is 2, that is 1. Now where do we put that 2? We put a 2 in front of this. So the calcium now becomes 2, making the calcium on the left and the right same, and oxygen on the left and on the right same. So balancing your equation, this is the final equation you have. 2Ca plus O2 forming 2CaO, 2 calcium oxide. So this is the balanced simple chemical equation, and that is balancing of simple equations. So for your assignment, I want you to write a chemical formula of the following binary compounds. So magnesium oxide, we don't just write the symbols for the atoms, but you make sure the valencies are looked at, and then you balance it up to give us the right answer. So if it is, say, magnesium oxide, I don't want to see MgO, I want to see Mg subscript something, O subscript something, depending on the valence. Then with question 2, you are balancing the following chemical equations. So just like I just did, you balance these equations for us. Take time. You can go through the video 2 times, get a good understanding, and solve your assignments, and then you submit. So the timeline is on the platform. Know when to submit and submit it. And please, BEC is fast approaching. We are in July, so we have from July to August, August to September, September to October, 3 months to finish preparing for our BEC. So please take your studies serious, both at school and then commit to personal studies. Personal studies cannot be replaced by anything. Thank you so much for your time, and I wish you the best. Do take care, stay safe, and stay serious as a committed BEC candidate. Bye.